Today we're going to refresh how to solve a system of equations. This is something that you learned in Algebra 1, but we're going to refresh it because now we're going to apply it to geometric situations. So, there are two main methods for solving systems of equations without graphing them. The first one's called substitution, and the second one is elimination. So, substitution is where you would isolate a variable. So, I'm noticing, like, in this first equation, my y is already by itself, so I would isolate, don't know how that happened, isolate the y, so I would subtract the 5x from both sides, so that would be negative 5x plus 9. And then I could take negative 5x plus 9, and now I can go substitute it into the second equation for y. So instead of y, I can write negative 5x plus 9 equals negative 18. So this is substitution. So first I isolate one variable, so I isolated the y by subtracting 5x from both sides. Then I went and plugged it into the second equation. So now I've gotten rid of my y's. Now I only have x's, and so now I can solve because I just have one variable. So now I'm going to distribute that negative 7, so that would give me positive 35x minus 63 equals negative 18. So this gives me 45x, and then if I add the 63, that's going to be 45. Divide by 45 on both sides, and x is 1. So to get y, now I'm going to go plug 1 back in for x into this equation. So y is going to be negative 5 times 1 plus 9. I'm plugging the 1 in for the x, and so that gives me 4. So x is 1, y is 4. And so I can double check this by plugging x is 1 and y is 4 back into both of these equations to make sure that it checks out. So 5 times 1 plus 4 should equal 9. It does indeed. 10 times 1 minus 7 times 4 should be equal to negative 18. 10 minus 28 should equal negative 18, and negative 18 does equal negative 18. Cha-ching! So both of these answers work for both of these equations, so we're good to go. So that first method was substitution. I isolated one of my variables and then plugged it back into the second equation. Another method, same problem, different method. So that was substitution. This is elimination. Elimination means that you're going to try and get one of your variables to cancel out. So I notice I have a 5x and a 10x, and if I wanted to cancel, wanted to eliminate my x's, I need them to have the same coefficient but opposite sides. So for example, does 5x cancel out with 5x? No, because that just gives me 10x. Does 5x cancel out with 10x? No, they don't have the same coefficient. 5x eliminates with negative 5x. That gives me 0. Those cancel out. So what you want to do is you want to get them to have matching coefficients, opposite signs. So if I'm going to try and eliminate my x's, I want them to have matching coefficients. So 5 and 10, well, if I just multiply this first one by 2, if I multiply everything by 2, then I'll have 10x and 10x, so that's good. But I don't want positive 10x, I want negative 10x. So I'm going to multiply everything by negative 2. So here's one of the most commonly made mistakes. I don't just want to multiply the 5x by negative 2, I have to multiply the whole equation by negative 2. So I'm going to have to distribute that negative 2 to everything. So that will give me negative 10x minus 2y equals negative 18. Now, my positive 10x and my negative 10x cancel each other out. They're eliminated. See ya! Positive 10x and negative 10x cancel each other out. Negative 7y and negative 2y gives me negative 9y. And then negative 18 plus negative 18 gives me negative 36. And so now I divide by negative 9, and y is 4, which is what we got last time. That works out nicely. And so now to figure out what x is, I can just go plug 4 back into either one of these equations. It doesn't matter. I'm going to go plug 4 back into one of the equations and solve for x. I'm going to go plug it into the first equation. That one looks easier, smaller numbers. 5x plus 4, I'm substituting the 4 in for y, equals 9. Subtract the 4, so I get 5x equals 5. Divide by 5, x equals 1. And that's the exact same answer I got for when I did substitution. So either method is great. Sometimes it's easier to do elimination than substitution. For example, if I hadn't had this y already with a coefficient of 1, like I would have had to not only get rid of the x's, but then I would have had to divide. So usually you only want to use substitution if you have one of your variables that has a coefficient of 1. Other than that, it's usually easier to do elimination.